My name is Steve. Welcome to my shop. Today I've got a hayman job. A couple days ago I got a text from one of my neighbors and he sent me the pictures of a handle off of his log splitter that broke. And so he asked me if I could repair it, build a new piece for him. I said, sure, bring it on up. So here it is. I'll bring you in a little closer, show you what it is, and show you what I've got to do. Here's the handle, and this threaded into here. Why there's two pieces, I don't know. I don't know why they didn't make it as one length, or whether it's an extension. But it snapped off inside. You can see the broken bolt in there. And so I'm going to remake this piece. I'm going to see if I've got a piece of stainless steel to make it out of. But the first thing I've got to do is get that bolt out. Now I suspect that it's not that tight. And so I'm going to go mount this in my lathe. And I'll bring you over and show you how I'm going to go about extracting the bolt. I was able to mount the handle up in 5C collet in my collet block. The phenolic handle that's on this fit inside the 5C collet, so that worked out pretty good. Now I have mounted my tooling and a drill chuck in my tool post. And I'll go into a little bit more detail on why I did that when we get to that part of the project. But right now I'm taking a 5/16 center cutting end mill, and I'm going to just flatten the end of the broken bolt off so that I can drill it. I had to change out the end mill. The 5/16 was going to cut some of the threads, so I got a 1/4 inch in there. That'll still flatten the bolt out. Yeah, I'm not tight enough in the collet. I'm going to have to take that out and retighten it. It pushed it in, but I do think I flattened out the bolt. So let me reset up and I'll bring you back. Okay, that was interesting. The bolt is actually so loose in there that the end mill drove it in and bottomed it out, but it's still not flat, so I'm not going to be able to get a drill on it. So I'm going to see if I can get a little bit more material on it. Okay, I got it flattened out good. Whether you can see that in there or not, but it's nice and flat. So now what I'm going to do is I'm going to go in and drill it with a left-hand drill. And that is the reason why I put the drill chuck into the cross slide in the carriage, because if it was in the tailstock and the bolt started to back out, it would jam and possibly break the drill. This way I've got pressure, I can put pressure, and as I feel it start to unscrew, I can back it out and keep from breaking the drill off. So let me go over and grab a left-hand bit, and we'll see if we can get that bolt out of there. Okay, I got my left-hand drill bit in there. Let's see how we make out. Now, that drill must be dull. It didn't do a thing. My camera turned off at some point. I'm not sure where it turned off, but you may have missed that. But this has backed the bolt out. It grabbed it and backed it out. And if I had had that drill in the tailstock, I never would have been able to react fast enough to back out, and I wouldn't have been able to back that screw out. So there it is. The left-hand drill backed it right out. So I got to measure that, check the thread on it, and then we have to measure. Then we'll machine up the extension and thread two ends on it. I've got my piece of material all prepared. I didn't have a piece of 1/2-inch stainless, unfortunately. Although this whole thing has turned out to be metric. But what I did have is a 3/4 inch stainless bolt, and I was able to turn that down to the size required. And so now I'm going to turn this end down to 10 millimeter. It gets threaded 10 by 1.5. Okay, I've got 1.37 millimeters to go. .20 millimeters, which is a little less than 10 thousandths. Let's see how I do with my metric figures here. See how I did. Right on the money. 10 millimeters on the button. I had set my 10 millimeters, and so it's down to 0, which means I'm at 10. So what I'm going to do now is cut a radius thread relief. Even though I'm going to just use a die on this, the original piece has quite a thread relief on it, and I'm using a small radius tool to help cut down on the being a stress riser there. Right, now I want to cut a chamfer to start the threading. I'm actually going to use my threading tool, because that'll give me the 30-degree chamfer. Alright, now let's get set up to cut the 10mm threads. Okay, here's my setup. I've got the die and the die stock, and I've got my spindle locked, and I've got the tailstock spindle locked up to keep the dies straight, and okay. I'm going to do, as I've got it started now, I'm going to take it out of the chuck. I can't get the tight chuck. I can't get the chuck tight enough to hold it. It's spinning in the chuck. So I'm going to take and put it in my soft jaws in the vise, and I'll finish threading that over in the vise. Okay, I'm going to finish cutting the threads over here in the vise. I use some anchor lube. It seems to work out really good on stainless steel. I have to put the die in the die stock kind of upside down, because the of the larger diameter of the shaft. Okay, that's bottomed out. Now I'm going to turn the die over so that I can go up against the shoulder with it. Okay, I'm making my final cuts on this end down to 8mm. Got 0.51, which is 20 thousandths. Okay, and down to 0. Perfect. There it is. So now I'm going to cut my relief. Actually, I'm going to put the chamfer on it first, because I've got that tool handy, and then I'm going to put the thread relief in there. Okay, I'll get ready to put the threads on that. I'm not sure exactly where I left off. I went to get the threading die for this 8mm by 1.25 and found that neither one of my two complete tap and die sets for metric had an 8mm in them. I don't understand it. One of them's almost new. There was nothing missing out of it, and they had 9s, which is ridiculous because I've never seen a 9 in the wild. So I had to order in a new die, and I'm going to get that set up in my die holder, and we'll cut the 8mm thread. I'm going to use some anchor lube on here. I've got my threading adapter hooked up. I'm going to try and do this under power. I haven't used this die holder too much, and when I have, it's been for smaller threads, and I never needed a handle on it. I may end up needing to put a handle on it, but let's see how it works. The new die is a round die. The old ones that I had in the set were the hex dies, so the hex die wouldn't fit in my holder. So let's give it a try. Okay, well, I got it started. I can't hold it in this holder, and rather than get involved with putting a handle on that, I'm going to take it over to the vise. I got it started straight, and I'll put the die in a die stock, and we'll finish it up in the vise. Nice new sharp die. Threads quite easily. Like I say, the anchor lube works particularly well on stainless steel. Okay, that should do it. Okay, the handle fits. So let's get it cleaned up and we'll wrap this job up. Well, here's the part. And I just noticed that this had a flat on it for a wrench. So I'll have to take it over to the mill and we'll set it up and mill a wrench flat on it. But this fits in there. It fits nice, and that threads into the machine. I have been working on this project off and on for a couple of days, and in reviewing some of my footage, I realized that I may have done something that when I was using my caliper, I showed it a couple of times with all zeros on it. And I know that many of my viewers know exactly what I was doing, but I'm sure we've got some viewers out there that don't. So what I want to do is explain to you. Typically I don't use digital calipers. However, there are a couple of circumstances when they come in very handy. One is when we're converting back and forth between fractional and metric. And the other is when I'm machining down to a number. For argument's sake, I'm going to be milling down to this flat now. And in metric it measures 0.965966. Nominally it's actually to fit a 10 millimeter wrench. But I'm going to change it to, well, shoot. I just zeroed it out on that dimension. And actually I'm going to change it to fractional now because my mill is in fractions. So it's zeroed out. Now I'll measure the outside dimension, and that leaves me with 108 thousandths to go down to where the flats are. So in this particular case, I would be split that in half, so I would have 52 thousandths cut on each side to get down to that dimension. And when I hit that dimension, I'll have a 0. And that's what I was doing on the lathe before. I had measured the diameter in one case. I had measured the diameter of the screw that I was going to be threading. And when I got down to the size of it, it was down to 0. And that's what I was showing you on the video. I showed you when I got down to 0. So I'm going to be doing the same thing again on the mill. And I'm measuring the flat. I'm zeroing it out. And now we'll go over to the mill and I will be milling down to that 0. So let's go back over to the mill and get started. I forgot to turn the camera on before I machined this. Darn it. Yeah, the flats are machined. My 10mm wrench fits on there. And now we'll measure it with the caliper. And there I am. I'm at 1,000th, if I can read that, 1,000th under. I'm back down to 0. 1,000th is well within tolerances for this. So that finishes up this part. I'm just going to go deburr it, and I will meet you back over at the workbench to wrap it up. Okay, I've got my part all ready. This is the original one. I had the broken off thread. So I'm going to put a little bit of blue Loctite on it. Woo! It's gotten thin. And that's ready to give my neighbor a text and tell him he can come pick it up. Well, that's going to wrap up this video. I've got a couple more that I'm in the middle of working on, but this is the last one that'll be posted before Christmas. I expect to have another one out next week before the new year. But just in case, I want to wish all my viewers a very Merry Christmas and a Happy New Year. And I particularly want to thank all of my subscribers for sticking with me through a time when I have not really been present on YouTube. I'm putting together a Shark Bits episode, and I'll go into more detail on where I've been during that video. I also want to thank all the new subscribers. I picked up over 300 new subscribers, even during the time when I only posted about, I think, 3 videos over 6 to 9 months. And I really appreciate those that have come on board. We're closing in on 5,000 subscribers, and when I hit that mark, we're going to do something special, but that's a little premature right now. I got a ways to go. Thank you for watching, and I'll see you in the next video.